So welcome back. We are going to look at building this portion right here. And keep in mind, this is going to be slow. I'm going to go through this very carefully and take time to have conversation along the way about all the things I'm doing. Why do I say this? Well, because even this simple, seemingly simple part here has a lot of things to talk about. So that's primarily what this video is going to be about. So I'm going to come over here, and I've already got it named Pulley Case Vid because it's me doing the video. If you're following along, you don't need to call it that. And I want to pick a plane, but remember this is going to be an assembly, so it really doesn't matter which plane I choose because I can orient however I want when I get into bringing it into the assembly. So I'm going to pick this sketch plane right here, go into Sketcher, and this time make sure that you have your horizontal and verticals lined all up before you click the background, okay? We'll do this, and then here's the conversation. If I go over here, I have this shape. I need to define this. There's dimensions in a lot of these things like this that are going to be missing. If you have to measure it from a real product, then you can measure whatever you want. If you and your company have a very solid, orthographic drawing that was done really well, then yeah, you'll have every dimension. But if you're getting it from something like this and you're trying to reverse engineer a thing, what usually happens here is they give you enough dimensions to know that you're purchasing the right product that you need for your use case, but it doesn't give you everything. So there's going to be some guessing, okay? I would say don't worry about that. Let it be okay. I would also say places like McMaster-Carr, Fastenal, the hardware stores that offer CAD drawings, let that be your textbook. If you need more practice, go find parts to build from there and use these, like I said, as your guide. So to get started, how am I going to draw this? Well, you saw what the shape is. It's going to be just this kind of an outline. And we have some dimensions, like we have 4.5 right here for the pulley outside diameter. And you notice it goes right to that middle line right there. I'm going to go ahead and use 4.5 inches, and I'm just going to call this good, okay? I could guess and say that it's 4.6, maybe. I guess we could say that. Maybe we will do that. I'm not sure yet right now. I just kind of want to make it easier. So when you look at this number right here, you say, okay, that's the one I'm going to use. And then I need to know height, and that's my 6 1/8. 6.125 is going to be that right there. But there's a couple things we don't know, like this width right up there, and we're going to have to guess this. That's okay, like I said. So if we look up here, this is 1 1/4 inches. That hole is 1 1/4 inches. It's a little bit bigger than that. So yeah, so maybe we can say that maybe it's 1.5 inches, possibly, okay? So those are our numbers. Now the next thing, if you look over here, how do I want to start this? And is it a big deal? Does it matter to me? Well, always think ahead. If you haven't figured this out because of the way I talk all the time about this, everything you do in a professional CAD environment requires a bit of foresight, a bit of looking ahead to see if the way you're just grabbing the tools and going about designing it, is that the best way for the future for editing, for others, and the whole story that I say all the time, okay? So I'll move this off to the side, and I'll go ahead and start drawing this out. You could put the circle right here in the center, but I feel like putting the circle down here. So I'm going to hit it like this and open it up. Now, the bottom of the shape here is not a circle, is it? It's a teardrop shape. But you see, kind of like we have this little hidden line right there. We could surely use that circle as a guideline, couldn't we? So if we want to use something as a guide, but we don't want to have it be part of the real part, how do we do that? Well, we click on this, and right there, construction element, or down here, construction element. So I turn that on, click on the background, it's dashed. If you use this one down here, by the way, realize that do you see how it's on still? As soon as I hit it, it's a toggle button, it stays in. So if I want to do another circle over here, it's going to be a construction element also. So you have to get used to kind of a habit of click on the background and hit that, okay? So I have this as my guide, and I'll go ahead and I'll add a dimension to this, and I'll make it 4.5 inches. So I hit this, and I say 4.5 IN, hit enter. By the way, I'm already in inches. I did not have to type IN. It's a little bit of a habit. Now I need to connect the rest of this. I could move this down a little bit. Oh, Oh, I did something and I didn't tell you as I did it. Do you see this little O right there in the center? That is a coincident, and that is coincidental to the vertical axes right here. I purposely let it snap. Watch me do this again. So I grab a circle, and you see how it snaps to that line, or down here, it snaps to that horizontal line right there. If I click right here and then open it up, I get that little O, and that means that if I try to move it up and down, it won't go up and down, but I can move it side to side. So that's a constraint. It's locked there. So apologies for not telling you what I was doing as I did it. So I've now got this locked at 4.5 inches diameter, and I have it anchored over on this line. So in assembly mode, when we talk about degrees of freedom, it's kind of the same thing, right? So we're getting this thing locked down. About the only thing it can really do is go up and down. So we'll handle that in a moment. The next thing to do is I'm going to use either the line tool or the profile tool. I'm going to use the line tool right now because we don't use that very much. So it's just going to draw a line. I'm going to go up here. I'm going to snap to that line, and I'm going to bring it down here. Now notice, you see that right there? If I were to click right now, this line will be tangent to that circle, but it won't be connected. What I would like to do, if I was tricky, is I could get up here somewhere on this. And you see that icon right there that's the circle with the line through it there? That means I'm on the line, and somewhere along the way, maybe I could also get the tangency. But I'd probably say don't worry about it. Don't worry about it. Just watch this. Bring it up here somewhere on the left of center. Just anywhere. Get it right there and click. Call it done. So there's my coincident right there. It tells me that I am stuck on to that circle. If I grab this and move it around, you see that it's stuck. Great. Let's do it again. So come over here, snap to that line, come down here, and snap somewhere to this. The reason I don't care about where we click is because we're going to make a coincidence afterwards. So I pick this, and this pops out so I can get constraint. I pick this, but you see it wants to measure the length. Well, before I click anywhere else, click the circle, and now it's going to give us icons, constraints that are only applicable to these two objects that I selected. Out of habit from using the older CATIA versions, yes, you can pick this. This is what I want right here. This is a tangency, but I can also right click and I can say tangency. I also like doing this in the videos because you can see the words. You know that this is what this is. So I hit that, and now I've got a line that is on the circle, and those two little lines right there means that it's tangent. So it'll be smooth. That's an easy way to describe it, is a straight line that goes smoothly into this arc. Okay, so then let's do the same thing to this one. So I'll go here, I'll pick that, and then I'll pick this circle edge anywhere, and then right click and say tangency, and now it's good. Okay. The next thing to do is grab another line, and we're going to connect this one. Get right on the point. See the dot in the center there? Not there, because see, that's on a line. Get right on the dot, on the point, right over there, and there we go. So we got this closed down. So we're almost good, and it looks like it's about right. We still got a couple more constraints to do, but remember how construction elements work. If I were to exit out of here right now, I don't see that circle anymore, and I can't extrude this. I can't pad this up unless I used what they call a thin feature. I need to have this solid all the way around. So I'll go over here. I'll open the sketch back up. And then what do we do? Well, as usual, a whole lot of things we could do. I'm going to use the 3-point arc starting with limits, is what they call this. So let me show you really quickly how these arcs work. Here's 3-point arc. Here's 3-point arc starting with limits. I know, it's a big name. So this one works like, just remember 1, 2, 3. Point 1, point 2, point 3. So point 1, point 2, point 3, and it makes an arc. Okay. The other one, if you were to think of it as dots, like I said, like 1, 2, 3, this is 1, 3, 2. So you do the first, you do the last, and then you pull the middle out, and then you click. I think this one, the last one, 3-point arc starting with limits, is the better one to usually use. My personal choice. So I pick this, so I can come up here and I can get right on that point. And then I get right on that point right there, and I stretch this out until I snap to that line and click. And now it is anchored onto that construction circle we made. And I'm hoping that also this sheds some more light on why we use construction geometry to help us build things. So a couple more things at least that I have to do. You see how this one is off to the sides like this? I need to get this centered. So if I want to center something, do you remember how we centered 2 points across an axis? So watch this. I'll hit constraint, and then I'll pick that point right there. I'll pick this point right here, which makes a measurement, but then I right click and I say allow symmetry line. So I hit that, and then I hit this vertical line, and now we saw some stuff jump around a little bit, but now these, I can move them, I can stretch them out, but they're symmetrical across the center line. Okay, next thing, I need to, how about this? We'll go up here and we'll dimension this. How about we make that 1.5 inches, like I said. If it doesn't look right, we'll come back and we'll edit it. Now, the next thing here, which might be the last thing, is this 6 1/8 from the top to the bottom, okay? So that's pretty easy. Click on the background so that you're deselecting anything, hit your constraints, and I can pick this line right here to this circle, but be careful. See how if I pick that circle right there, it goes from to the short side. If I hit constraint and I pick this one to the other side, then it will measure that dimension. So this is going to be 6.125. By the way, if you are in the United States or if you work with the United States and they're using the imperial system, get used to figuring out what fractions are. So for example, 6 1/4 is 6.25. 6 1/8 is 6.125, so on and so forth. Now notice everything changed colors because it is ISO constrained, or again, the word that we have learned from assembly, there are no degrees of freedom. It's not quite the same thing because I can't rotate this around and such, but it's completely fully locked down. And so now we can exit out of here and we can pad this up. We're almost done. So I go to pad this. Let's get back over to here. And this is the part that I mentioned briefly as we were going through the thing, that if I were to pad this out, let's bring this thing back here. This right here is supposed to be 2 1/4, so 2.25. So if I go 2.25, I'll hit tab. It goes out like this. But now my plane system is all over on one side, and just because it seems like a symmetrical part to me, I would like to build it symmetrically just in case that becomes helpful in the future. And I know that that probably doesn't make a lot of sense now, but maybe just hold on to the idea that if I could make it symmetrical, that might be beneficial, and then just keep building parts, and then you'll decide if that's a valid thing or not. So what I want to do is I want to hit this button right here. So if I hit this button, it makes it symmetrical, but it's 2.25 on both sides. So what I want to do is make it 1.125, half of that. Or if I wanted to, I could also get rid of 1in. I could say divided by 2. I could let it do the math for me, you see? So now we know it's 2.25 wide. I can hit OK, and my plane system is right there in the center, okay? So that's a lot. That's a lot for just getting the lump of the pulley case done. We've got a fair amount more to go, but that'll do it for this video, okay?